Hi there, I'm Sean and this is the Marine Robotics Group's Introduction to Microcontrollers tutorial. So, what is a microcontroller? Well, a microcontroller consists of a small chip and a lot of pins where you can use the chip to control a bunch of peripherals plugged into those pins. Now, one common cause of confusion is the difference between microcontrollers and single board computers. A lot of times they're confused. But typically, single-board computers, or SBCs, are typically built with better computing abilities and are designed for use with an operating system. They're more of a full-fledged computer, whereas microcontrollers work at a lower level, usually with a specific purpose, though sometimes they can run what's called a real-time operating system. So first we'll cover the input and output, then some communication protocols, and then some available options out there for microcontrollers, and then a basic Arduino sketch. So, microcontrollers are equipped with what's called general purpose input-output pins, or GPIO pins. And these are programmable and usable as the name suggests, input or output. So digital pins have two common modes, that being input and output. And when in an input mode, they can read in high or low signals. So that's like whether or not it's above or below a certain voltage threshold. So you can use these with things like buttons and switches or sensors like photodiodes, and they're often used in conjunction with pull up or pull down resistors, which sort of provide a default state, if you will. And a lot of times these resistors are built into the microcontrollers and can be set with software. By default, pins are input on Arduinos. When pins are on an output setting, they're setting the output voltage to high or low. So this is often like 3.3 or 5 volts versus 0 volts. And they can be used as a source or a sink. They provide enough power for small peripherals, LEDs, small sensors, etc. But usually you don't want to use them directly with more higher power components like motors or solenoids or other high power peripherals. Now, a special set of pins, called analog pins, are actually capable of reading analog signals. So they can actually read the voltage from, say, like 0 to like 5 volts. So these are great for sensors that operate on a change in the output voltage. This is made possible using what's called an analog to digital converter circuit, and the resolution of this is based on what kind of ADC you have built into your microcontroller. Analog pins can also be used as digital pins, but not all digital pins can be used as analog pins. Now, on the other hand, if you want to simulate an analog signal, then you actually use a digital pin using pulse width modulation. So what pulse width modulation does is it varies the duty cycle, so you end up with an average voltage that's somewhere in between the maximum and minimum. So if you have like 50% duty cycle, and your maximum is 5 volts and your minimum is 0 volts, you get an average over time of 2.5. Using something like a capacitor, you can actually smooth this out to get something pretty close to an analog signal. Now, we've moved on to communication, and the first thing we'll talk about is serial. But no, not that serial. This serial. So, on Arduinos, you're typically communicating with them over USB, and that's actually working through a serial connection, in this case a UART connection specifically. And in this communication protocol you have two wires, the TX or transmitter, which sends data, and RX, which receives data. And you have the TX connected to the RX of the other device, so you have two pairs of TX-RX and RX-TX, as you can see in this diagram. They communicate on a predetermined data rate or baud rate, and often in Arduino tutorials you see like baud rate is set to like 9600. This is very important so to have them match, so you actually have the devices able to talk to each other, and you can make sure this is correct when you open the serial monitor when you're, say, working on serial communications between the device and your computer. Some other communication protocols we have are SPI and I2C, and these are also alternative communication protocols. They're often used with other integrated circuits or ICs which provide all sorts of other functionalities. They might act as switches, or you might be able to use them for like reading temperature data. It really depends on the chip as to what communication protocol you're going to want to use. And I recommend looking into these more specifically on their own when you come across them. Now here are two largely available devices. They're both Arduinos, the Arduino Mega and the Arduino Uno. There's a whole bunch of microcontrollers in the Arduino line, and then there's the more recent Pi Pico, as well as the Teensy line, and all sorts of other ones, like ones by ST Microelectronics, but these are just two of the big ones here. So the Uno is one of the most ubiquitous microcontrollers out there for beginners. And then the Mega is practically just an extension of it. So as you can see, the Mega has far more pins. It's in general a much more capable version of the Uno. Now, if you don't own a physical Arduino, that's okay. You can use a simulation. Now, this isn't an endorsement or anything, but Tinkercad has simulated Arduinos along with a bunch of tutorials on their website, and I think it's a pretty good resource if you don't have your own physical Arduino and associated electronics. Now, some basic components you'll probably want to be familiar with, especially when you're just getting started, are the LED, which I'm sure most people are familiar with. It's a light-emitting diode. And then you also have resistors, which provide resistance, and then potentiometers, which are variable resistors. You turn the dial and the resistance changes. So oftentimes you'll use a potentiometer as an input device and read the output on an analog pin on a microcontroller and use that as some sort of way to put your own values into the program using like a dial or something. And then you might use that to say change the brightness of an LED using a PWM pin. So Blink is the definitive Arduino program. So it's actually technically called a sketch. A sketch is just an Arduino program, and there are two main functions. So you have the setup function, which runs first and, well, sets everything up. And then you have the loop function, which is just a continuous loop that runs over and over and over forever and ever and ever. And you can actually add other functions outside of these that you can call inside the setup and loop functions. So for example, the pin mode, digital write, and delay functions, those are all separate functions, though they are like provided by default, but you can create functions that are similar and use them in the same way. So I think the best way to get to learn microcontrollers is starting with tutorials, getting your feet wet, and once you feel like you know enough, you can start working on your own ideas and consulting the internet on the way. So here's some two basic tutorials that I think are probably a good start. First is fading a LED. It's rather simple. It's just using PWM to adjust the brightness. And then the next one puts a bunch of elements together, including the brightness, and then combining it with reading a potentiometer through analog pins, so you can just control that brightness with a dial and also read those values in a serial monitor. This slide deck was created by myself, Sean Fish, and Aaron Wu. And thank you for watching, and good luck.